Assalamu alaikum. Today we will talk about concurrency control. We need the concurrency control to solve these three problems. The first one is the loss of data problem. This problem occurs when two transactions access the same data item, have their operation interleaved in such a way that the one transaction will access the data before the other one has applied any changes, which will result in incorrect value of the data item. Then we have the temporary update or dirty reader problem. This occurs when one transaction updates a database item and then the transaction fails for some reason. Then the updated item is accessed by another transaction before it changed back to its original value. So the second transaction will be reading a false data. And the third problem is incorrect summary problem. If one transaction is calculating an aggregate summary function on a number of records while other transactions are updating some of these records, the aggregate function will be calculating some values before they are updated and other after they are updated. The purpose of concurrency control, as I demonstrated before, it will solve the three problems, which is the dirty read, the lost update, and the incorrect summary. So it will enforce isolation among conflict transaction, and it will maintain the database consistency and resolve read-write and write-write conflict. So if two transactions has a conflict between them, the concurrency control will decide which transaction will terminate and which one will complete operating. The lock is a variable that is associated to a data item. For each data item there is only one lock. So the lock will describe the status of the item with respect to possible operation that can be applied to it. This means that the lock will show is it allowed to write or read from the data item.
The first technique in two-phase locking is binary lock. First of all, in the binary lock, we have two concepts. The first concept is locking, and the second is unlocking. The locking means set the value to 1. The unlocking means set the value to 0. Okay, what do you mean by locking? Locking is an operation which allows only one transaction to read or write. On the other hand, the unlocking means removing all locking and making the data item free. Here are two algorithms used by binary lock. The first algorithm is lock item X. In lock item X, first we check if the lock sets to 0, it means that the item X is free and unlocked, so the transaction can lock the item X. Else, if the lock sets to 1, it means that the item X is not free and locked, so the transaction should wait until the lock manager wakes up this transaction. The another algorithm is unlock item X. It's so simple. The item is set to 0, so the item X now is free, and if any transaction wants the item X, the lock manager wakes up that transaction. As I said before, it is not allowed to more than one transaction to work on the same data item. So we have a waiting queue. What does it mean? The waiting queue handles the transactions which are waiting to the data item to be unlocked and get the item. Here are some rules applied on binary lock. The first rule is, before performing any operations of reading or writing the item, the transaction should lock that item. Second rule is, after completing reading or writing an item, the transaction should unlock that item and make it free. The third rule is, if any transaction lock an item, this transaction will not issue a lock for this item because it's already locked it. Fourth rule is, a transaction will not unlock the item unless it already holds that item and locked it. Based on detectability, which kind of schedule does match the use of the binary lock? For sure, a strict schedule, because it doesn't allow multiple transactions to work in the same item, as I said before.
The second technique is about the mode of the locks. We have two locks mode. The first is the shared lock or the read lock. The second is the exclusive or write lock. The shared lock, we can apply it on a data item when we want to read the value of this data item. The other transaction can apply also the read lock on the same data item and read its value. But no transaction can apply write lock and update the value of this data item. The second type is the exclusive or write lock. Only one transaction can apply write lock on the data item and update its value, but no other transaction can apply the read lock or the write lock. Here we have the algorithms for the read lock and the write lock. In the read lock, the transaction will check first if the data item is unlocked, then it will apply the read lock on this data item and set the number of reads to 1. The second case is if the data item is locked by a read lock, then the transaction will increase the number of reads and read the value of this data item. The third case is if the item is locked by a write lock, then the transaction will wait until this data item become unlocked and the logs manager will wake up this transaction. In the write lock, the transaction will check first if the data item is unlocked, then it will simply apply its write lock. But if the transaction is locked, then the transaction will wait until this data item become unlocked and the logs manager will wake up this transaction. Now we have the unlock algorithm. If the data item is locked by a write lock, we will simply unlock this data item and we will wake up one of the waiting transactions. But if the lock is read lock, then we will need to decrease the number of the reads, and if the number of the reads becomes 0, the data item will be unlocked and will wake up one of the waiting transaction. The system that use the shared and the exclusive locking it must enforce some rules. The first rule states that if a transaction wants to read the value of data item, it must apply a read lock or a write lock to ensure that the data item will not be changed. The second rule is that if a transaction wants to perform a write on a data item, it must lock this data item by a write lock or exclusive lock. The last rule is that if a transaction finish all its operation on a data item, it must unlock this data item. And based on recoverability, which kind of schedule matching this use of the shared and the exclusive locks, there is no schedule match this type of locks.
The third technique is lock conversion. So there is lock upgrade. If I have to start with data item X, I want just to read data item X, then I need not to acquire exclusive lock. So I acquire a shared lock on data item X, and then I can read this data item X, but later on, if I want to write operation on this data item X, in that case, before I perform write, I have to upgrade this lock and I have to do a lock that is exclusive lock on database item lock. So this upgradation of lock. So similarly, that write is over. If I want to perform a read or some other transaction want to perform read, then it won't be allowed because it is exclusively lock. So what we do in two-phase locking technique, we can downgrade the lock. So downgrading of lock is that after write operation is done, we do a lock S, that is be downgrade the lock on this data item, and then other transaction can perform read. So this is lock upgradation and downgradation. So now let's understand what do we mean by two-phase. So when we say two-phase, it means that this locking and unlocking has two phases, and the first one is called growing phase. So in growing phase, only locks are obtained but not released. It means that only lock will be obtained in this phase but no lock will be released in this phase. So a transaction applies locks on desired data items one at a time. This phase can include upgrade phase. Next phase is shrinking phase. In shrinking phase, only locks are released but no new lock will be taken. Transaction unlock its locked data items one at a time. This phase can include downgrade phase. So this is growing and shrinking phases.
As we said before, using binary locks and read-write locks in transactions prevent confliction between them, but it does not guarantee serializability of schedule. And this example proves that by applying these values in the first transaction, then the second transaction, we get a result. But when we apply these values in the second transaction, then the first transaction, we get different values, which means it's not serializable. Here, another example that shows even if the transactions done concurrently with locking and unlocking, we get different values, which means it's not a serializable schedule, which means not all transactions use locking and unlocking are serializable and obey two-phase locking.